Hello students, welcome to another video under Learn Concepts Through Problem from Numerical Methods. In this video, we are going to understand the concept of integration by trapezoidal rule, Simpson 1/3 rule, Simpson's 3/8 rule, single step and multi-step methods to solve ordinary differential equation. In single step, we have Euler's method, Taylor series method, RK2 method and RK4 method. In multi-step method, we are going to see modified Euler's method and Picard's method. It is important to know here that all multi-step methods are iterative in nature. Then we are going to solve GATE, MT, previous year question from these topics. Let's get started with the concept. First one is integration by trapezoidal rule. Trapezoidal rule. It is a numerical method of integration to find approximate area subtended by the function between the interval. Now graphically we will understand the trapezoidal rule. Suppose that we have this graph like this. This is A point, this is C point, this is B here and this is D here. It's x0 0, x0, x0, y0. This is x comma y and this graph function is fx. During the integration, area under this function is divided into trapeziums, divided into equal intervals. Suppose that this number of interval here is n, starting from first. In this method, there is an approximation that the line connecting the two adjacent steps are through the straight line, and by connecting these straight lines, we are actually approximating these figures as trapezium, and then we will calculate the area of this trapezium. So the approximation goes here is linear. This trapezoidal rule is derived from Newton-Cotes formula, where we have taken n equals to 2 and these steps are h and number of subintervals are n. Now we will write the formula integration x0 to x1 f of x dx equals to h by 2 y0 plus yn plus 2 into rest of the terms, where h is the step size. Sometimes this is also called delta x. N is the number of subinterval, and there is a formula to calculate the step size, that is h equals to x1 minus x0 upon n, that is x1 is the upper limit minus lower limit divided by n. Now we have understood the concept and now we will solve previous year question. This is GATE 2009 question. According to the question, what is the magnitude of the following integral using single step application of trapezoidal rule? In each question, we are going to write three things: function, fx, subinterval, and step size. So first of all we will write the function fx equal to 3x square plus 4x minus 2 subinterval. In the question it is written that we have to use single step application. So single step application means n equals to 1 and step size h we know that its upper limit that is 2 minus lower limit that is 0 upon n. So this is 2 minus 0 by 1. So we will get 2. Now we will write the formula integration x naught to x1 fx dx equal to h by 2 first term plus last term plus 2 into remaining terms. So according to the formula now we have to calculate the value of the function at these intervals. So we will write so x starting from 0 and there is a step size of 2. So next step would be 2 and we have only one subinterval. So this is done. Now we will write this is y0, this is y1. Now we will put the value of x in the given function here. Now what we will get? By putting x equal to 0, we will get minus 2. Again in the function, this one, we will put value of x as 2. X equals to 2. We will get 3 into 2 square plus 4 into 2 minus 2. That is 12 plus 8 minus 2. We will get 18. So we will write 18 for y1. Now we are ready to substitute the value. So h we know the step size 2 by 2. What is the value of y1 here? Y1 we have got as minus 2 plus the last term. Last term we have is 18 and rest of the term. So in between we do not have any terms. So it will be 0. So after solving we will get 1 into 16, that is 16. So for this case 16 is the right answer. Moving to the next question. This question came in GATE 2022 for 2 marks. Now we will read the question. The integral of the function fx equals to 0.2 plus 10x square estimated by the trapezoidal rule with a single segment from x equal to 0 to x equal to 1 is. Like the previous case, first of all we are going to determine the three things. These three are function, subinterval and step size. So we will write the function first. Fx equals to 0.2 plus 10x square. Subinterval as in the question it is given that we have to perform in a single segment. So n would be 1. Step size h would be calculated by subtracting lower limit from the upper limit. So it would be 1 minus 0 divided by the value of n, that is 1. So it will be 1. Again we are going to write the formula, that is integration from x0 to x1 f of x dx equal to h by 2 first term plus last term plus 2 into remaining terms, that is y1 plus y2 plus y3 and rest of one second last one. Now we will determine the value of y0, y1, y2, y3. So we will write x, y. According to the question, the segment starts from 0 and next step size is h. So it will be a 1 here. Value of the function y0 y1. Now we are going to put x equal to 0 in this equation. So we will get 0.2, and again we will put x equals to 1 in the above equation. So now we will get 10.2. Now we will put the values directly. We have h as 1 by 2 into y0 is 0.2 first term, and the last term is 10.2, and for this question we do not have any middle term, so it will be 0. So after calculating we will get half of 10.4, it will be 5.2. So 5.2 is the correct answer for this question. 5.2 up to 1 decimal place. Moving to the next question. This question is from GATE 2018. Using the trapezoidal rule with two equal intervals n equals to 2 and delta x equals to 1, the definite integral we have to solve. That is integration from 2 to 4 of 1 by ln x dx. Like the previous cases, we are again going to determine the three things, that is the function value, subintervals and step size. So now we will write the function. Function fx equals to 1 by ln x. Subintervals is given in the question, that is n equals to 2. That is number of subintervals. And the step size is also given as 1. So now we will write the formula. Integration x0 to x1 fx dx equals to h by 2 first term plus last term plus 2 into remaining terms. Remaining terms are y1 plus y2 plus y3 up to yn minus 1, the second last term, because last term we have already counted here. Now we will draw the table. We will write x, y. X should start from the lower limit, that is 2, and should increase by the step size h, that is 3, again that is 4, the upper limit. Now we will write the function value. y0, y1, y2. We will get y0 when we will put x equals to 2 in this function. After putting x equals to 2, we will get function value as 1 by ln 2. Again, when we will put x equal to 3, we will get 1 by ln 3, and similarly 1 by ln 4. Now we will substitute the value. The step size h is given as 1 upon 2 into y0, that is 1 by ln 2 plus last term, that is 1 by ln 4 plus 2 into remaining terms. Like the previous cases where we do not have any remaining terms or the middle terms, but now in this case we have the middle terms, this one. So we will write 2 into 1 by ln 3. Now 1 by 2, 1 by ln 2 plus this one I can write 2 ln 2 using the log property plus 2 by ln 3. Now taking the LCM and solving, we will get 3 by 4 ln 2 plus 1 by ln 3. After substituting the values of ln 2 and ln 3, we are going to get the final answer as 1.9923. So up to 2 decimal for this question, 1.99 is the correct answer. Moving to the next question. This is question from GATE 2020 for 2 marks. Like the previous cases, again we are going to proceed by writing three things. The solution using the trapezoidal rule of the integral, this one, by dividing the range 0 to 1 into two equal parts. Now writing the function fx equals to e to the power minus x square. Number of subinterval n given in the question as two equal parts, and interval is given as 0 to 1. So we will write the step size h equals to upper limit 1 minus lower limit 0 divided by 2, that is n. We will get 0.5. So now we will write the formula integration x0 to x1 f of x dx equal to h by 2 first term plus last term plus 2 into remaining terms y1 plus y2 plus y3 up to second last term yn minus 1. Now we will draw the table. Now we will write the value of x, y. So this x should start from 0, 0, and it should increase by step size 0.5, and then again 0.5, that is 1, to the upper limit 1. Now we will write the corresponding function value for x equal to 0. By putting x equal to 0 here, we will get e to the power 0, that is 1. So y0 equal to 1. Now we will put x equal to 0.5, e to the power minus 0.25 by squaring 0.5. y2 we will get, putting x equals to 1, we will get, now we will substitute the value equal to the step size we know is 0.5 by 2 into the first term 1 plus the last term e to the power minus 1 plus the remaining terms 2 into e to the power minus 0.25. Now we will put e equals to 2.718, and by calculating from calculator we will get 1.3679 plus 1.5576 by 4, that is 0.73. So for this question 0.73 is the correct answer. Now moving to the next question. This question is from GATE 2007. According to the question, the probability distribution function Px for a random variable x is given by this one. Probability that x lies between x1 0.6 and x2 0.8. So again we will write the three things like the previous one. So function value fx is given as px 1 by root pi exponential minus x square. In the question it is given that we have to use single step trapezoidal. So number of subinterval n equals to 1. Now the step size h equals to upper limit, that is 0.8, minus lower limit, that is 0.6, divided by number of subinterval, that is 1. So it will be 0.2. Now we will write the formula as this one and draw a table x, y. So we will start from the lower limit, that is 0.6. Now we will increase by step size 0.2. So it will be 0.8. Now we will determine the value of the function at x equals to 0.6. So we will write 1 upon root pi e to the power minus 0.6 square. which would be 0.036. For 0.8, we will write 1 upon root pi e to the power minus 0.8 square. So we can write this as 0.64. Now we will substitute the value as h, that is interval, is given as 0.2 by 2 into the first term 1 by root pi e to the power minus 0.036 plus the last term 1 by root pi e to the power minus 0.64, and for this case we do not have any intermediate terms, so it will be 0. Now after calculating we will get a value of 0.069. So for this case 0.069 is the correct answer. So option B is correct. Now moving to the next question. So this question is from GATE 2014 for 1 marks. According to the question, in the trapezoidal rule for numerical integration of a function, the nature of approximation used for the function in each interval is. So during the theory we have seen that, suppose that this is a function, so according to the approximation from one interval to the other interval, we have taken an approximation that during the each interval function joining is through a straight line like this, through a linear line. So we have done this approximation. So for trapezoidal, answer is linear, that is option B. Now we will understand our next topic, that is Simpson's 1/3 rule. This method approximate the area under the curve by dividing it into parabolic section, the second degree polynomial. So now we will understand the concept with the help of diagram. Suppose that we have this diagram y, x. Suppose that we have this curve. This is from x0, this is up to x1, this point is x1, y1, this is x0, y0, and we have function fx. Now when we will divide the intervals into sub intervals, we will approximate in this section as joining the two intervals, it will be like parabolic. Like in the previous case in trapezoidal, we have taken this as linear, these subinterval parts as linear, but now we will take this as parabolic, which will form a much smoother curve and better fit. These are interval h, that is the step size, and these are number of subintervals. Again, like the previous case, the step size h is given as delta x, upper limit minus lower limit divided by number of subinterval n. In this case, it is important to remember that n must be a even number. So now we will write the formula: integration from x0 to x1 fx dx, it will be h by 3 bracket first term plus last term plus 4 into summation of odd indices plus 2 into summation of even indices. So odd indices here mean that these terms are y3 plus y5 plus y7 and all odd terms, whereas even indices means all the even terms, that is y2 plus y4 plus y6. So this is the formula. Now we will understand this with the help of example. Example, I is given as integration 0 to 6 x square dx. So the necessary condition here is n should be even. So we will take n equals to 2, the number of subinterval. We will write the step size h equals to upper limit 6 minus lower limit divided by number of subinterval. So we will get 3 as step size. Now we will write the formula, that is x0 to x1 f of x dx h by 3 first term plus last term 4 into odd terms, that is y1 plus y3 plus y5 plus 2 into even terms, that is y2 plus y4. Now we will draw a table. X, y, the lower limit is 0, so it should be 0. It should increase by step size 3. So next value is 3. Again the next value is 3 added, so it is 6, the upper limit. Now we will calculate the value of the function at x equal to 0. It is 0. It is 9 and this is 36 when x equal to 6. So now we will substitute the value h, that is step size equal to 3 by 3 into the first value, this one 0, plus the last value, that is 36, plus 4 into the odd terms, so it is 4 into 9 and there is no even terms, so it's 2 into 0. Now we will calculate. This is 136 plus 36, it is 72. So answer for this question is 72. Here a important things to observe, that the value of the integral comes to be 72. So when we calculate from our traditional method, the integral value will also come to be 72, and this is the exact value. This exact value is coming because we have taken the function as x square, which is a quadratic or parabola, and the approximation goes into the function is also a parabola. So for this case we have got the exact answer. We will get the approximate value for higher order polynomial. Now moving to the next method. This method approximates the area by dividing it into cubic, that is third degree polynomial. So now we will understand with the help of diagram. Suppose that we have this graph. Here it is x0, here this is x1. Now during the third degree polynomial approximation, between these intervals, each step, the function is approximated as a cubic function, and this cubic function supposed to match with the given function, so that approximation error could be minimized. Like the previous case, we have the intervals and whose step size is h and the number of subinterval is n. Then we can write step size h equals to upper limit minus lower limit divided by n. In this case, the Simpson third eighth, the value of n should be multiple of 3. So this is the necessary condition. Now writing the formula, we have I, that is integration 3h by 8 bracket first term plus last term plus 3 into y1 plus y2 plus y4 plus y5 plus and plus 2 into multiple of third terms 3 y6 y9 etc. Now we will understand this with the help of an example. I equals to 0.3 e to the power x dx. So number of subinterval n equals to 3 given. So we can calculate the step size h equals to upper limit minus lower limit divided by number of subinterval. So we will get 1 as the step size. So now we will construct a table. We have x, y, and starting from the lower limit we have 0 with the step size 1, 2 and 3 is the upper limit. So we have y0, y1, y2 and y3. We will get y0 if we substitute x equal to 0 in the function fx equal to e to the power x. So on substituting we will get 1. Again if we substitute x equal to 1 then we will get e. On substituting 2 we will get e square and similarly e cube. Now we will write the formula, that is I equals to 3h8 first term plus last term plus 3 into the not third multiple terms, that is 1 plus 2 plus y4 plus y5 plus 2 into the multiple of third terms y3 plus y6 plus y9 etc. On substituting we will get the value 3 into 1 by 8, 1 the first term plus e to the power cube the third term plus 3 into e plus e square, and there is no multiple of third term, so it will be 2 into 0. On calculating we will get 3 by 8 e cube plus e square plus 3e plus 1. So on putting up the value equal to 2.718 we will get 19.277, which is the correct answer for this question. Now we will move to another concept, that is single step and multi-step. Look at the concept of single and multi-step ordinary differential equation. So what is ordinary differential equation? This is when differential equation dependent on only a single independent variable. Single step is getting your answer in one step, whereas multi-step is a iterative process. Ordinary differential equation mainly in the form of dy by dx equal to f of x comma y, whereas y is given as something value. This is called the initial condition. Now we will understand this with the help of diagram. So the diagram is y, x, and suppose that we have graphs something like this: x naught, y naught, y1, and this is the solution curve. First we will look at the single step method, and in this case the first one is Euler's method. According to this, the formula is y1 equals to y naught plus h into f of x naught y naught. This solution we have got after linear approximation of solution curve. So the next method is Taylor series expansion method. In this method, y1 is written as y1 equals to y naught plus h into y naught dash plus h square into y naught double dash by 2 factorial plus h cube y naught triple dash by 3 factorial, and it goes on. As we are going to take the higher terms, the error in the approximation will be less. So the next method is RK2 method. In this case, y1 value is y0 plus delta y. Delta y is calculated as half of k1 plus k2, and k1 equal to hf x0 y0, k2 equal to h into f of x0 plus h y0 plus k1. So first of all we will calculate the k1 terms, then we will calculate the k2 terms where k1 is required, then with the help of k1 and k2 we will calculate delta y, and then finally, so now we will see RK4 method. Similarly we have written RK4 method here. RK4 method is similar to RK2 where we have written y equal to y0 plus delta y and delta y is equals to this one. So in this formula, first we need to calculate k1, then k2 where k1 is required, then k3, then k4, and then everything we will substitute k1 to k4 in this, and we will get delta y, and after that we will get the value of y1. So GATE is never going to ask numerical question from this section because the calculation becomes very tedious. So there will be a theoretical question from this section. So we have to understand the concepts and understand the formula very well. So now we will move to the multi-step ordinary differential equation method. In this section we have modified Euler's method, Picard's method, and Adam-Basforth method. In this case, Adam-Basforth method is a two-step method, whereas modified Euler method and Picard's method is a multi-step iterative method, where we solve the equation until the two consecutive value becomes the same. Then we will stop the iteration. Now we will take few questions from these topics. The question is, which of the following method is not used for numerically solving an ODE? Just now we have studied that Adam-Basforth method is a two-step multi-step method for solving ordinary differential equation. RK method is a single step method for solving ODE, and Euler's method is also a single step method for solving ODE, whereas Newton-Raphson is a iterative technique to solve non-linear algebraic equation. So for this question we can easily say that Newton-Raphson method is not numerically used for solving differential equation. This question came in GATE 2011 for 1 marks. According to this question, which one of the following method is not used for numerical integration? So we studied that trapezoidal method is used for numerical integration. Rectangular method and Simpson method is also used for numerical methods for numerical integration calculation, whereas Cramer's rule is used for solving the simultaneous linear equation. So for this question, Cramer's rule is not used for numerical integration. This question came in GATE 2012 for 1 marks. With this question, we conclude the video, and hopefully you understood the concept and ready to tackle any problem from numerical methods. Thank you so much for watching the video.